Anyway, it's a pleasure to be here. Thank you for having me. I am the chairperson of the department, and we're waiting and all kinds of stuff that it's just murky. It's not much fun. You just got to do it. So this is a good data for me to get away. I appreciate the opportunity. So I am going to talk about kind of what we've learned here in the last 20 years or so about the age and evolution of coastal sand dunes along Lake Michigan.
I'd just like to ask Dr. Arbogast where you're from. You said that you came 20 years ago to Michigan? So
yeah.
I'm just kind of curious about what came before for you.
Yeah, what came before? A lot. At deep time, I don't even remember. Kansas.
Kansas? Okay.
Yes, I grew up in Topeka, went to the University of Kansas, got my PhD there.
Any sand dunes in Kansas?
Lots of sand dunes.
Are there?
Yeah.
Really?
Yeah.
Well,
That's how I cut my dune teeth. Yeah. So yeah, it's I lucked out and got a good job here studying dunes. So I have been working with Brad Garman at the Michigan Environmental Council, and along with some others, we've been trying to work on kind of a new way of using the science of coastal dunes, what we know about them and their evolution, in management in some way, shape, or form. It's a kind of a convoluted story how dunes are managed in Michigan, and I'll talk a little bit about some of the ways that's been done historically and what contributions we might be able to make. One of the ironies is you asked where I'm from, so Kansas, I grew up in Topeka, and Brad, who's the Director of Conservation Emerging Issues and for the MEC, he's a Kansan as well. So a couple of flat dry landers are up here on one of the world's great coastlines talking about dunes. So like I said, I am from Kansas, and I worked on dunes for my dissertation. This is a typical slide, a good representative image of part of the dune field in south central Kansas. I've lived in 2 states where you can easily identify where you're from, right? Michigan, okay? For my home state, all you gotta do is that. And I grew up there. My 2 daughters are at school at Kansas there right now, and I studied dunes in the south central part of the state, and that image is from about that part of the country. So this is, dunes are dunes no matter where you go. What makes a dune is the fact that it's a deposit of windblown sand. And this is an interior dune field, like the Sahara or the Nebraska sand hills, and that all you need to have is available sand that can be moved by the wind. Most of this sand is from the Rocky Mountains originally, derived from there, from the granites and whatnot from those igneous deposits in the Rockies, and then they were carried onto the plains along the Arkansas River, and then during dry periods that sand can be blown up to form dunes like this. Now these dunes aren't particularly large. Most of them would maybe be 2 stories tall, something like that. You get some sense of scale here. They would be along the Michigan coastline. You would hardly even notice them. But here in the plains, they're distinctive because they cover much of the area, really. 60% of Nebraska is covered by dunes. I'd say 15% of Kansas is covered by dunes. And they tell us something about climate change in the past. This is a drought-driven system out here, where cycles of drought in the past, what the impact of that is that the dry conditions reduce the vegetative cover, plants die, sand is exposed, and so long as that is the case and the wind blows hard, then sand will move. Okay? This is a pretty good example. This is a field trip. I still run a field trip to the plains with one of my classes every couple of years, and this is from 2004. This is along Rattlesnake Creek in the southwestern part of the dune field, not too far from Dodge City, if you remember Gunsmoke. But 20 years ago, this is actually an interesting slide because 20 years ago, the landowner tells me that when he was a boy, he grew up there, Rattlesnake Creek had water in it all the time, even during dry periods. It was a groundwater-fed stream. He said it was never more than that deep. It was nice, cool, clear water, and they'd go down there and play, and this would be like a little oasis back in the day, right? But because of heavy groundwater mining, the Ogallala High Plains Aquifer you've heard about, water tables dropped so much that creek hasn't had water in it in 25 years. And so it's easy to imagine that wind blows across the surface, desiccates it even further, moves that sand up here, and that's how the dunes in that part of the system run. All right, now I was lucky when I came here in '95. I was lucky enough to get the job because MSU was advertising for a geomorphologist specifically, which is what I am. And I came up here armed with my dissertation, knew that there were a lot of dune fields in Michigan. I'd done a little bit of homework, and that they hadn't been studied much, ironically. And so I made the play that, hey, I know something about dunes, you have a lot of them, please hire me. On top of that, my wife was 4 months pregnant with our first. I need a job. And so, I was lucky and I got the job and it's worked out great. So this is a map, a fairly crude one. This is the geography of this. I am kind of a geologist on the one hand. One of my feet is firmly planted in the geological sciences, but the other one is very much geographical. I think about where things are, why they're there. And this is a map of dunes in Michigan. And so, it's not comprehensive, but it gives you a good feel of things. Obviously, the long stretches of coastal dunes, but there are a lot of dunes in the interior of the state, a lot of them. These, in terms of their size, look much more like the plains dunes. They're not as big as magnificent coastal dunes along the lake, but they're dunes nevertheless because the sand blew them, or excuse me, the wind blew them. This is the Saginaw Lake Plain here. This is near Houghton Lake, and then there are a smattering of dunes scattered here and there. The Seney Flats. If you're driving across the UP from Newberry and whatnot, any little mound that you see is a dune field, is a little sand dune. I've studied a lot of them, including this one near Houghton Lake. This kind of gives you a representative idea of it. This is an old lake plain from the glacial era. This is a dune. Here's another one there. Gives you some sort of sense of scale. These are now forested heavily. And so the question for me is, well, when were conditions right for wind-blown sand to accumulate in this part of Michigan, which is not a place where you would think of that, right? Because, it's all forested now, there's no way the sand's going to blow. So when was it right? Well, we've dated these dunes. This is what we call the Roscoe Dune Field. Nice parabolic dunes here on this map. They indicate that the wind was from the northwest at the time that the dunes formed, and we are able to date them with a method called optical stimulated luminescence, and we know that that dune field was active between 14 and 11,000 years ago. So the story here is that just as the ice was leaving, this was heavily glaciated, of course, as ice was leaving, it took some time before plants moved in to populate the landscape, and so we have bare deposits of sand at that time that can blow and form dunes. And so that tells us something about what the conditions were like. We know when the ice was there, which way the wind was blowing, that sort of thing. And so that's pretty interesting in and of itself. But the dunes that everyone associates with Michigan, and properly so, are the magnificent coastal dunes. And I've been lucky enough to work on them for quite a while now. Now, when I give these talks, and I've been giving a lot of them lately because Brad and I have been kind of doing a road show where we're trying to spread the gospel of coastal dune evolution in the state, because our sense of things is that it's not well understood. So trying to raise that awareness in some small way. And when I give these talks, I like to point out that these are really world class. Michiganders, I've been here a long time now, and I got a pretty good feel for this. Michiganders tend to be fairly parochial. Michigan. It's not easy to get to. You don't drive through Michigan on the way to someplace else unless you're going to Canada, right? And so Michiganders have a tendency to, hang out in Michigan. Most people do. A lot of people do. That's cool. But in the same time, it's like, don't take this landscape for granted because it's awesome. Here's a representative slice of some dune fields I've worked on. This is north of Liverpool on the Sefton coast. That's the Irish Sea over there on the right, and nice coastal dune field. Anybody would like to go there. I asked my students, who would like to go to Liverpool? Who want to see? Oh, yeah, sure. Well, that's the place to go. All right, a lot of dunes along European coastlines, Italy, Portugal, France, the Baltic, all over the place. And they look a lot like the one that I just showed you. Okay, so these are coastal dunes and places that anybody would like to go visit, for sure. Here's the southwestern coast of Australia near Perth. I was there in 2008, and every American student I've ever met, for the most part, wants to go to Australia. And so here you go, nice dune field there for sure. North Island of New Zealand, north of Auckland. Beautiful coastal dunes. Yeah, fantastic. Oregon even, a little closer to home, Pacific Northwest coast. You don't have to go that far, right in your backyard.
Just a quick question. I'm looking, based on what you just showed, look at prevailing winds from the west. Is that where most dunes?
Yes.
Like you don't see those on the east coast of the United States.
Yeah, you see there are some, but they're not as large and as grand as they are here. The westerly winds are the
driving force.
Yeah, that's really the driving force for the biggest dunes. The old roaring 40s that you hear about in physical geography texts. So just a quick, you guys know this probably better than me. Just magnificent landscapes. Sleeping Bear, of course, Camp Minnewaca, which is toward the middle part of the coast. Nice shadow dune there. Ludington, near Holland. Now, I started working on these dunes when I first began working here, and I'm still kind of in some ways more impressed by them than I am up here, because they're so big. They're just gigantic things. And the first time I saw them, after walking out of the plains, and I'd worked on my little, 2-story high dunes, which got me where I needed to go, and they were interesting for sure. The first time I saw these things, I couldn't believe it. I really couldn't believe it. I just stood there and I went, "You've got to be kidding me, that they're this big."
Are those your daughters?
No, that one's not, but that one's my youngest. She's now a freshman at Kansas.
Time flies.
It does. It does. Oldest is a senior there.
These are not perched on a moraine, are they?
No. These are on an old lake terrace, which is only a couple of meters above modern lake level. So that's what is really impressive about these, is that they're most of what you see there, 90% anyways, windblown sand. So that's interesting.
Are they still moving?
Some.
I guess that's
Yeah, we'll get there.
Okay.
We'll get there. Good questions. All right, so again, the geographer in me wants to know, well, why is the west coast of Lower Michigan such a prime spot for coastal dune development? There are dunes on the Door Peninsula over in Wisconsin, Whitefish Dunes over there, and there are some dunes on the east side of Lower Michigan, but they're small, kind of wimpy things. There's a nice dune field over here on the Ontario side, and there's a little dune field right here in the thumb that's kind of worth looking at. But the best dunes are those. Why is that? Well, we like to think, geographers in particular, we like to think in an integrated way, putting pieces together. Westerly winds, for the most part, right? It's a long fetch across Lake Michigan. That's a fancy way of saying that the air can flow cleanly across the lake for 70 miles. And the first part of the landscape it hits is the coast. Sand grains, boom, blows them up into dunes. And lots of sand from the ice ages. Michigan's a big sandbox. So the conditions are right, even though this is a heavily forested place. All right, so the dunes are very heavily utilized, and this is, I think, something that the state needs to come to grips with in some way, shape, or form in the coming decades. I don't know how that's going to happen. It's complicated, but they're a big playground, right? Warren Dunes down below here. They're favored places for homes, for obvious reasons. Great place to live, good views and all of that. And they're heavily mined in places for foundry sand. This is the Sargent Sand Quarry near just south of Ludington. As you go into Ludington State Park, if you've been there, you drive right by this big sand quarry just as you're going into the park, which is an interesting juxtaposition. Yes, ma'am.
What are those shadowy things and step-like things on the dunes there at the state park?
Here?
Yeah. No. These things.
Oh, those are parking lots.
Oh.
Yeah.
I was thinking they were home footprints.
No,
that had gone
that's the
down.
parking lot.
Oh, okay. Thanks.
Yeah, sure.
I didn't see any dunes in the picture in Grand Sable. They are perched on a moraine, but
They are. Yeah,
but I didn't see them on that photo, on that picture of the UP.
right. Yes, ma'am.
I had a question about the Keweenaw Peninsula. You showed that previous map of Michigan, and you show all the sand dunes. The Keweenaw curves out that way along Superior. That's all rock, isn't it?
Mm-hmm.
Now, why is that?
That is Canadian Shield, ancient.
No sand.
Yeah, there's very little available sand there that
Okay.
can blow. And that's one of the things you have to have, is you have to have a lot of available sand for it to blow. And by available, I mean it's there, it's unconsolidated, it's loose, the air can move it.
Yeah, there are places up there where the sand will blow across the road, but in general, it's rock.
Yep.
Are you going to talk a little bit about the consistency of the sand in terms of being used by the, because some of the sand is better for that than others.
Well, I can do that right now. It's why are the Michigan dunes so heavily mined? I mean, again, it's a good. Let me back up. Good questions, by the way, and I appreciate it. It's always good to talk about to groups like yours because you guys get it and you ask questions. You ought to try teaching a group of freshmen something. And this is the average look. Every now and then there's a flicker, but there's a lot going on in there. And where's my phone? But it's a geographical exercise, really. I mean, if you think about the onset of the auto industry, and I mean, it was perfect. The sand, and more importantly, the sand is perfect for foundry because it's heavily lot of silica, which holds up well under heat and pressure.
Okay.
Secondly, it's extremely well sorted, and by sorting I mean that the sand grains are dominantly the same size. You've had that experience. You pick some of them, and it's all the same, right? It's Canadian Shield sand. It was brought here. Its origins are Canadian.
Oh.
That sand is the first illegal immigrant in the Great Lakes region, and so it's Canadian, and it was just ground up by the ice.
Okay.
And so the sand grains are all the same size. So when it comes to processing for foundry, you don't really have to do anything. It's perfect as it is. You don't have to separate coarser rock from it, or other things that might get in the way. I mean, it's almost perfect as it is, just in the dune. Now, I have had a student, concerns about sand mining through time, and I have had a student who worked on his master's thesis looking at alternative sources of sand for the foundry industry, and he took all the rail lines in Michigan, used the rail line as a center line, and then had a 2.5 mile a window on either side, and then he looked at the well log data for all of Michigan where deposits of sand are in those buffers, and concluded that there is a hot spot of all sorts of sand up here in Northwest Lower. And it's available, and it's next to a rail line, and you could get it down here pretty easy. But it would take more processing because it's not as well sorted as the dune sand. So who knows? Maybe one day the state will say, well, that's where you got to do it. But that means the cost of somebody's car is going to go up because it's going to take a little more effort to process that sand. Dune sand is perfect as it is, practically.
maybe electric cars will do away with the need for it.
Sure.
Wind-blown sand, dune sand, is it rounder and less angular as opposed
Yeah.
to sand that's mined somewhere away from the lake shore?
You know, I don't know about that, but the roundness of the dune sand is I mean, it's so uniform and it's so perfect. If you've ever seen, I should start doing this. I have a foundry mold in my office from the crankcase of an engine, and it just fits together. And then add a little bit of cementation to it, it's just done. Perfect. So, from an economic perspective, it makes sense. If you look at it purely from that prism, it makes sense to use this stuff. It's easy to transport, put it on a boat, it's in Cleveland in no time.
Is that state land or is that private that he can use? I mean, where the state's getting some royalties?
Yeah,
or
right.
something.
Yeah, but it's controversial, and the folks that live around there hate it.
Yeah.
In fact, I gave a talk 6 weeks ago in Ludington, this talk, essentially. And a lot of a group like yours, and they were just generally more on edge, period.
Does the sand go other places in the auto industry? Do we ship it all over? And what are the purposes? I mean, does it go all over the world, or we just use it here in the Midwest?
No, it's going all over the world, and mostly in the United States. And other than foundry, it's perfect for frac sand too. And that's where a lot of it's going now, more and more. And for the same reasons, because the air has sorted the sand out, and it's pure. It holds up under pressure beautifully. It's well sorted. I mean, it's ideal.
So what are the dangers of this mining operation in terms of the dunes, besides depletion?
There really isn't any.
Doesn't destabilize the dune?
Well, that's an interesting question. Does it destabilize a dune? What is an unstable dune? And that's a rhetorical question. That's a rhetorical question. And we can talk more about that later on when we get into some of this stuff, because different folks have different interpretations about what a stable dune is and what an unstable dune is, and how one is different. It's really pretty interesting. Myself, I've never really waded into that stuff until recently, because I'm just interested in the age and the evolution of the dunes and what that means. But these are great questions. They really are. Uh-oh. There we go. Okay. All right. So, in the context of all of these heavy uses in the dunes, they've been managed pretty heavily. Beginning in the 70s, you may know something about this. Of course, this is coming out of the environmental movement in the 60s. Higher profile about those kinds of sensitive landscapes. There were a fair number of people living on the lakeshore, mostly, that were quite offended and bothered by mining. This is well before my time. I was in high school. I graduated from high school in '76, so I wasn't paying attention to this. And some famous dunes were destroyed. Take it like Pigeon Hill, for example, a little farther south from here. Near Muskegon is one of the more famous ones, where people who felt strongly about it were really bothered by the fact that it was mined completely. So, in an effort to balance all of these things, the state passed the Sand Dune Protection Management Act in '76, and that identified 275,000 acres as sand dune areas. Now, interestingly, it didn't cover all of the sand dune areas by any stretch, not even close. But these were sort of deemed to be the best. And there were the first regulations on sand mining that were applied at that time. That act was amended in '89, again before my time. But someone in my department was involved with this, Dave Lush. 75,000 acres of the 275,000 acres were deemed critical dunes. And that designation was based on height, extent, height any dunes that were larger than 20 feet high. And if dunes on average were over 20 feet high for 2 miles along the shore, then that was a critical dune area. Also some unusual plant communities, and say high preponderance of pitcher's thistle and those kinds of things. If all those things fit together, and the dunes were at least 20 feet high for 2 miles of the shore, then those were critical dunes. If you want to call that arbitrary, fine by me.
Well, there was a standard of review, though.
Oh yeah, there was a standard of review, but what in my mind, just as a hypothetical exercise, what makes a dune that's 20 foot high any more critical than one that's 15? But that's beside the point. The state was grappling, trying to come up with some way of managing this landscape. And there were additional regulations that were applied to development. For example, in some of the cases that I've been involved with, and there haven't been many, I don't want to make it sound like there's been a lot, maybe a half dozen. And for example, and maybe some of you in your own experience have had some dealings with this, if you have a home on a sand dune, on the crest of a dune, and you want to add a deck to it, someone from the state's going to come out and they're going to say, okay, is this deck being built on a slope that's greater than 30%? If it is, then theoretically that is, quote, harming the dune in some way, if the slope's greater than 30%. Personally, I find that it's situational in my mind. So, but this was an effort to come up with something that was standardized. All right, this is where I walked in with this background. And I'm coming up out of the plains, and I'm impressed by these dunes, and I'm starting to kind of walk into these things. And the beautiful thing for me is that these things hadn't been studied in any kind of meaningful way.
Yeah.
It was astounding for such a high-profile, genuinely cool landscape like this. I even go so far to say that it's cooler than in my home state, and that's hard for me to say. I love Kansas. I love the plains. I can wander around out there for days. But as far as coast, this is pretty top shelf, and it hadn't been studied. The only scientific mention of them in a kind of a meaningful way, there had been some work done on the ecology. We had talked. Coles, for example, in early 1900s. Yeah. Jerry Olson in the 50s had done some work on the ecological succession in dunes, which was revolutionary for the time. But in terms of the age of the dunes and how they formed, there hadn't really been any work done. The Geology of Michigan is sort of the Bible of Michigan earth sciences.
Yeah.
Written by Doran Eschman in 1970. And here's how the whole book, it's books like that thick, 4 pages are devoted to the coastal sand dunes. And this is representative. This is, I should have the page number on here, but I don't. This is an image of worn dunes taken from their book. And here's how they describe this in the caption. It says, blowouts, okay, blowouts, due to wind action on shoreward side of old high dunes related to higher water level of Glacial Lake Nipissing. If you're up on this terminology, which can be pedantic, Glacial Lake Nipissing was a high water phase about 5,000–6,000 years ago. Had to do with the way the lake system was adjusting to deglaciation and some climate change added in there. Bottom line is that the Lake Michigan, Lake Huron, were on the order of 15 feet higher than they are now. There's evidence for that on Lake Street out here. If you're driving up from the beach, you'll come up on a little terrace like this, and then there's a little bluff. That bluff was formed during this high water phase. And they're really prominent up here. So the lake was 15 feet higher than it is presently. We know this for a fact because you can see it on the landscape, the evidence for it, like I just described. And there's been some folks, Todd Thompson at the Indiana State Geological Survey and others. Lichter had done some of this work too, John Lichter, looking at reconstructing lake level fluctuations in the big lakes
Yeah.
for the past 5,000 years. And here is the curve from Lake Michigan. And this work's been done in embayments. There's a way of coring and measuring the elevation of beach deposits and whatnot. And the long and short of it is about 5,000, 4,500 years ago in there, here's where Lake Michigan was. And modern levels here. Now, the lake fluctuations that go on presently in the historic, in our lifetime, they can be annoying, somewhat threatening, periodically. If lake jumped 15 feet overnight, everybody'd freak out, for sure. So it was very different at that time. And the assumption is that as the lake fell from that high phase, back up, as the lake falls from the high phase, there was a lot of sand available on a very wide beach, and that's when that sand blew up to form the dunes. So that's why you see terminology like higher water level of glacial Lake Nipissing. Okay? All right, intuitively it makes sort of some sense. There was a lot of erosion during this high phase, the lake drops, sand's everywhere, it blows up to form the dunes. So that's on the one side. Now, on the environmental side, looking at it, say, from the standpoint of the Lake Michigan Federation, this is a document that was published in 1993. I've worked with Tanya Cabela some, who used to be with the Lake Michigan Federation, and I don't mean to sound like I'm knocking this, but when I arrived, here was the kind of terminology that you saw regularly. Now, keeping in mind, this side is interested about sand mining. They're concerned about sand mining for logical reasons. So, vanishing Lake Michigan sand dunes, threats from mining. So here's very flowery terminology. Here's from Carl Sandberg. Those dunes are to the Midwest what the Grand Canyon is to Arizona and the Yosemite to California. They constitute a signature of time and eternity. Once lost, the loss would be irrecoverable. That's pretty big. And so here's some stuff I copied. The sand dunes were created in the last ice age. Lake Michigan's rare, internationally unique dunes were created over 10,000 years ago as the glaciers receded and the wind blew sands along the shore. That's just wrong. I can understand the motive, and I get it, but both of those statements are wrong. So, all right, that's how they were described. They're either Nipissing, forming all in one time, more or less, or they're older than that, and they formed right after the ice left, and those processes are never to be repeated. Me, I'm interested, I just want to know how old they really are. Okay? So I start looking at this literature a little bit. A lot younger at the time, and I'm going, well, what's chronology? Well, there wasn't one. It was all based on assumptions, which was lucky for me. So I started working, I'm living here. We have our first child 2 months after we move here. I want to make my mark. I'm trying to learn some stuff and get started, but I also want to be close to home. My wife's going, all right, get tenure. You need to get tenure, but don't be gone too long. And so I'm working over there. The geography is excellent, and it's a really interesting topic to work on. All right, so here's what I saw first time. I'm on the beach, and I'm thinking, well, these things, the scientists are saying that they're Nipissing dunes, one-timers, more or less. The environmental side is saying, whoa, irreplaceable, all this stuff. I go, well, what's the truth? So I'm walking along the beach. This is at Van Buren State Park, which is down here. And this is what I see straight away. And I'm like, nope. Because you see these dark lines here? Mm-hmm. Those are old soils. This is organic. Charcoal, wood, Plant fragments, dead trees, ghost forest. I'm seeing these things and I'm like, those things didn't form all at one time. There's no way.
Yeah.
They had to grow in stages. Had to. It's that simple. And the astounding thing is that it hadn't been done. Because this is, in terms of an earth science kind of project, this is like taking candy from a baby. It's walking on the beach and going, wow. And also the presence of the organic matter, its character was like, there's no way this stuff's 10,000 years old. And also I know that the ice was, it hadn't been gone that long. So it's not fit with what the literature is telling on both sides, all kinds of sides. And so I had some money for my startup for, coming here, which is what we do. And I got some preliminary radiocarbon dates on the organics in these soils and started to build a chronology. And then I went to NSF and I said, hey, here's this landscape that 3 million people are going to every year. It's being yanked on from all kinds of different sides, but nobody really knows how old they are. Can I have some money and a grant, please? And they said, yeah. Off and running. So, here in the southern part of the basin, say south of Manistee, south of there, this is how the dunes look. They kind of grew in stacks. Up, like that.
So was there soil, were there plants growing at that level and then at the next level and the next level?
Yes, ma'am.
Okay.
So what happened was that sand blew into here, okay, and then it stopped. And it stopped long enough for plants to colonize the surface. And that surface must have been, the way we look at it, is that surface must have been stable. Stable meaning that it's not being eroded, nor is sand being added to it, for enough time for it to be colonized to the point where there's an organic remnant left. I'm thinking this is 150 years of time. And then sand is added to the system again, and it buries that old surface. And then that stabilizes and so on. So this thing is growing up through time. This surface was stable long enough for a forest to be on it.
So wasn't that Nipissing Lake or whatever, wouldn't it have interfered with that happening?
Hang on to that thought. I'll show you some dates here in a minute. Okay? Good. Now, that's the way it is in the southern end of the basin. These things grew up in stacks. The northern part of the basin, up here, it's different. Here, we're north of what's called the isostatic hinge line, which is, a hocus pocus term. But what that means is that this is the zero iso base. North of this line, the landscape has rebounded from the weight of the ice. The ice was so thick and so heavy that it literally pushed the landscape down. And then as the ice left and unloaded, then the mantle bounces back like a sponge. Like that. Sault Ste. Marie, this is just astounding to me, Sault Ste. Marie is still bouncing back this much every century to this day from the weight of the ice 10,000 years ago. That didn't happen in Kansas.
Why wouldn't it happen below the hinge line?
Because the ice, good question, the ice was a lot thicker up here.
Yeah.
A lot. The big hills and that you see and everything, the big moraines and whatnot, when you're driving around and you're looking at a big ridge, like Shush Mountain or something like Boyne Highlands, the top of that hill represents how thick that ice was. And you're driving well into the ice where it was at that time. And so that ice was thick. And down in the southern end of the basin, the ice would have been a tenth that thick. So it just didn't weigh as much. Good question, though.
What was the age of that lower level of vegetation soil? How long ago?
Hang on to that thought.
Okay, all right.
I have dates to show you.
All right.
All right, so you can see the evidence of this isostatic rebound up here. If you're looking at the shoreline around here, you see this all the time.
Yeah.
Go drive across the bridge, right, and go and look at Mackinac Island, and notice how it kind of stair steps down. That's that. And so when you're north of the hinge line, when you're north of that line there, wherever you are, that's what you're going to see. This is the bluff that was cut during what we call the Algonquin Lake phase about 13,000 years ago. Now, Algonquin, it was a lot higher because there was a lot of water coming off the ice as it melted. I mean, just think, springtime around here. There was a lot of water laying around, right? Well, magnify that a bazillion times, and there you have a lot of water going into the lakes. In addition, this was pressed down relatively, so it's a combination of both. Water's higher, but it's also down. This is rebounded. This is the Nipissing. That's the Nipissing bluff there. You don't see this in the southern end of the basin because the ice didn't weigh as much and it didn't bounce back. If anything, the southern end of the basin is subsiding a little bit, a tiny bit. So, Algonquin, Nipissing. 12,000 years ago, 6 to 5. And this is the surface where the dunes have grown since. Now, there's another animal up here that's different from the southern end of the basin, which is the famous perch dunes. These dunes, like Grand Sable and Sleeping Bear, they are sitting on a big stack of glacial sediment from the last ice age. At Sleeping Bear, most of what you see in this exposure is glacial. And if you're standing on the overlook, you can see gravel. See that gravel down there? That's all, that was sediment that was washing into Glacial Lake Algonquin 13,000 years ago. Which, that's a scale that, it's just hard to fathom. And then, here's the contact between the glacial and the windblown. The source for the windblown sand here is this exposure there. Wind hits that exposure, moves the sand up like that. So sand dunes there, glacial sediment below. There's what it looks like in real life. Here's the glacial sediment. This is the soil that formed at the top of the glacial sediment, and then this is windblown. You don't see this on the southern end of the basin because you don't have the big thick deposits of glacial sediment there, not like you do here.
So you're talking about the stuff that the glaciers push on the front line and the stuff that they pick up as they're moving, and that's what the glacial deposits are?
This glacial deposit here, in some cases that actually happened, in Boyne and other places, that kind of process occurred. Here, this was sediment that was actually being carried in streams that was washing into Glacial Lake Algonquin.
Oh,
this is sort of like a delta.
I get it.
I mean, it's the scale of this is, it's just hard to imagine.
Yeah.
It's huge, huge, huge. That part is never to be repeated for a long, long time, for sure. So this gives you some sense, and this is when next time you're at Sleeping Bear, this is just worth thinking about. The next time you're up here and you're looking way down there, you see these people doing the climb, and they go down. Our students go there and they go, "Oh, this is going to be fun," and they charge down there and they turn around and they got to get back up. And they're looking at me and I'm going, "Good luck." and this is the water that the sediment was poured into was at least this deep. It's amazing. So this is the soil between the glacial and the windblown. Okay. Here, close to home, I've done some work at Petoskey State Park, and these dunes are in little embayments, like Little Traverse Bay.
Yeah.
And this is a perfect spot because it's a nice little funnel where sand can collect and then it can blow and form these nice dunes. This is one of the first dune fields I worked on, in fact. Yeah, and you can see these.
Amazing.
This is Wilderness State Park, and the dunes up here are, what's interesting about them is that the older dunes are more inland, and the younger dunes are more the younger dunes are more lakeward.
Are those?
No, this is glacial.
Oh, that's
glacial. So the older dunes are more inland, the younger ones are more lakeward. So if you look at, this is photo from the Mara collection. You can see the sort of bathtub ring in the slide there. So as we go back like that, we know that you go this way, the dunes are getting younger. And the reason for that is because the lake plain here, which is the place where the sand is deposited by the wind, the lake plain is still isostatically rebounding. It's literally rising out of the lake through time. And as it does so, the next place where the lake, this surface is exposed is where the new dunes are going to grow. So, older, a little bit older, so on. Very predictable. And then when you get to Ludington, kind of halfway down, it's a little bit of both, which is what you would expect. I added this when I gave my talk at Ludington because, and then, so here's the park here, the sand quarry is right there. So literally, to get to the park, you have to drive by the sand mine. And the folks that are living here are really upset because sand is blowing and burying their decks and whatnot, and they think it's all from the mine. I don't necessarily know that that's true, but it's an easy hook. All right, so with that, it was like, all right, we got some money, let's date these things. How old are they? Two ways of doing that. One, which most everyone has heard about, is radiocarbon dating. And you're estimating the last time something organic was part of the life system. We're all organic. You know, I try to jazz it up in class. You know, when those freshmen are kind of staring at me, I go, all right, you know, you're all hoping that I'll drop dead at some point. And so if I drop and you leave me out there, you know, and you bury me, the organic, I'm not going to be part of the system anymore. And so the organic residue in my body is going to start to decay. And it decays at a known rate, and we can estimate how long that's been. All right. But you got to have organics to do that. There's a way of dating the sand grains themselves called optical stimulated luminescence dating, OSL dating, or optical dating for short. This is whoever, well, I know who, I don't know the person personally, but I know who it was. This method is based on, and it's really cool, even my wife, who's not a geographer in any way, shape, or form, love her to death, but you know, we each have our strengths. She gets fired up about OSL dating. Because she's like, talk about the dating thing. And the way it works is that the sand grain is blown by the wind. And most of the sand grains are silica rich. Quartz. That's the clearish grains. Those are really, really hard. Really resistant. If you look at the grain, I've enlarged the grain a bunch. You look at the grain on its edge, it has all kinds of tiny little fissures in it, in the lattice. And if that grain is buried, it's deposited, like that, and it's buried by more sand, and some of that sand has feldspar in it. That feldspar through time will decay radioactively, very slowly, not dangerous. And the little cracks in the quartz will absorb that dose. Follow me? Okay, so long as that grain stays in the dark, it continues to absorb dose. What I'm doing here is I'm collecting a sample for OSL dating. Got a radiocarbon date on that and that, but I want to know the date of the sand itself. So you paint a tube black, or you wrap it in duct tape 5 times, drive it into the side. The sand that's in the tube is in the dark still, right? Send it to a lab where some people, you know, working in a really weird light, they take the grains, they expose them to light, there's a flash. And that flash can be measured. And you can tell the last time that sand grain was exposed to light. And that is when the grain was last blowing. Pretty cool. And it's fantastic because there's a lot of times where you don't find organics in these dunes. All right, so armed with that, here we go. This is representative, and this is at Van Buren again, one of the first sites I worked on. And it sort of encapsulates a lot of the things I've been talking about. So those are lake sediments. One of the things that jumps out right away is this dark layer here, yep. That's organic as can be. In fact, it's an old swamp. About that thick. You look at it, smell it, smells like swamp. Serious. There's rushes and little plant fragments, and it's a swamp. And lake sediments here. All right, guys, where do you think those lake sediments came from? Based on what we've talked about so far.
Delta from the washout of the glaciers.
That would be a logical explanation. And in the northern part of the basin, yeah, that would work. But this is in the south. When would water have been high enough to deposit those sediments?
Algonquin?
Algonquin would have been way back. What's our next one? Nipissing. These are Nipissing sediments when the lake was 15 feet higher. And you get some sense of scale for that. There's my dog, there's a student, you know, that's about 15 feet. And that is the swamp, the wetland that was on the edge of the lake, just like when you're walking along the lake shore now and you see a swamp near the edge of the lake. It's the same, except a while ago. So there's the swamp, and you can trace it. You know, if you clean this back, like that, you could follow it for a while. All right, above that is windblown sand. So this is lake sand. That was deposited by the lake. That's the swamp that was there. That's dune sand above it, windblown. And we have some of these soils in there. All right, so we have radiocarbon date on the bottom. We have a radiocarbon date on the bottom and the top of that old swamp. And at 2 standard deviations. You can't just say Thursday 5,000 years ago this was. You can't do that. You got it's kind of a probability estimate. We know that that was a swamp between 6,000 and 5,000 years ago, which is perfect Nipissing time.
Are there trees in there?
Chunks of trees. Yeah.
I would think that would be called a marsh rather than a swamp, wouldn't it?
Yeah, marsh, sure.
Okay.
Yeah, marsh. When I smell it, though, I go, swamp.
Well, normally marshes are the ones that grow next to the Great Lake.
Yeah, sure. I follow it. Anyway, 6 to 5,000 years ago. Perfect. And then sand started to blow in, but it did so in stages.
Yeah.
Didn't do it all at one time. The old model would have been like after the lake fell from that, boom, that's when the sand blew, formed that dune. But not true. We know that sand accumulated, probably first accumulated about 5,000 years ago to bury the marsh. And then it stopped. There's a little soil right here. You see that line?
Yeah.
See that thing? We have charcoal from that dated between 4,400 and 4,000 years ago. There's another one there that dated between 3,700 and 3,300 years ago.
Uh-huh.
There's another one between 2,100 and 1,800 years ago.
Yeah.
And then that one up here, which was between 464 and 129 years ago, and then 2 in the last 300 years. So this thing grew up in stages. There were times when sand blew in, and then there were times that sand stopped. All right, let's go north of the hinge line, up here. Mm-hmm. One thing that's interesting about here, well, down here, there's lots of organics, lots of it. Because the dunes stopped and plants grew, okay, and buried it. Here, we don't have very many organics buried in these dunes. Because these dunes are different. Still windblown, but they grew this way. Why? Because the lake plane is rising out of the lake because of isostatic rebound. And so because of that, these dunes are not growing up, they're growing this way. So geographically, there's a difference between the northern end of the basin and the southern end of the basin. And because we don't have any organics, or very rarely do we have organics in these dunes, and we've looked a lot, we have a bunch of OSL dates, optical dates. We get up on top of these dunes, we take a core, we send the core off to the lab, they tell us how old it is. And this works out perfect. Here's the Nipissing Terrace between 5,000 and 6,000 years ago. In the southern end of the basin, that's when sediment was accumulating underneath the dune, before the dune was there. And then we have our dunes that the oldest dunes are there and the youngest dunes are this way. This dune growth we had know was between 3,500 and 3,000 years ago, 3,000 and 2,500 years ago, 1,820 years ago, 605 years ago to 475. Sweet thing is that even though it's a different geography, it's the same chronology. So sand was blowing in the southern end of the basin at the same time as it was in the northern end of the basin, regardless of whether it was growing up or whether it was growing out. It's the same chronology, no matter where you are, which is amazing to me. So here's what we've done. I know the question you're thinking. You're thinking, well, why did these things grow at some point in time, and why did they stop at others? That's the rub of it right there. So here's one way we're looking at this. We have 162 optical dates. I'm pretty sure that this is the best dated dune system in the world. 162 dates. This is a probability density, this is statistical analysis of all of our dates. And we're looking at probability. Probability of a date at a particular time. Back when I was 16, the probability of me having a date at a particular time was very, very low. Here we have different periods of time when the probability is high and high when the probability is low. These peaks represent a statistically high probability that sand was blowing at that time. So dunes were growing. Here, here, here. Does anything jump out at you? It's like, whoa. In terms of the probability curve? One is, look at that drop in probability right there. And look at that.
1,000 years ago.
1,000 years ago. This fascinates me. It is one of the big unknown questions. We call this period of time the Holland interval because there's a soil near Holland that we've identified that we can trace from Manistee all the way down to Indiana. This is the soil that had the trees in it, up high, the buried trees. The landscape, and this is like 700 years of time. The landscape was very stable, whether you're at the bridge or whether you're at Indiana Dunes. The landscape was there was very little sand blowing for 700 years in the coastal dune system. Wow. And then, bang.
Little ice age?
Medieval warm. Medieval warm period, and this is Little Ice Age.
Oh, I see.
Yep, this is medieval warm period right here.
No kidding.
And I know that there was sand blowing around in the plains at the same time. It was warmer and drier. When people talk about climate change in the future, one of the analogs is the medieval warm period.
So during that Holland interval, are we saying that the storms were not intense enough to actually blow around, the sand, or we don't know? We just don't know.
We don't know, but I'm looking for a collaborator, and the fact that you just asked that question is that's one of the things we're thinking about. Question? Is there no?
Well, I was going to say tie in the climate change because it seems that's the issue.
Sure.
What was going on?
Right.
Whether it's winds, the intensity of the sun, or whatever that triggers winds.
It is the $1 million dune question along Lake Michigan shore. So one of the things we tried to do is we tried to relate it to climate change, and we can relate it to climate change indirectly by looking at lake level fluctuations. We know that Lake Michigan and Lake Huron have fluctuated a lot. Lake Superior too, for that matter, has fluctuated a lot through time. Here, this dashed line is the curve that I want you to see here. This is the very intensively reconstructed lake level curve. 6,000 years ago on the left-hand side. This is the present, 0 years ago. You can see that the lake has gone up and down, up and down, up and down through time. But it's also had, in the course of the up and down, it's also had bigger peaks too. There's kind of a series of fluctuations that are built in. And so what's driving that? You know, how does that relate to climate change? Well, we know that between 2,000 and 1,000 years ago, it was cooler and wetter than it is presently. Question?
What is the blue on the top representing?
This?
Yeah.
That's another lake level curve.
Okay.
By a colleague of mine, and because he's a good buddy of mine, he always makes me put that curve in.
It's the same lake.
But he's not here right now, so I'm going to say this dash line is the one that I want you to look at, because I think that one's better.
Yeah, but as the lake level went down, that's when the sand could blow around more.
Yeah, well, okay, right. Is that what's happening? Is it because that there's more sand supplied when the lake drops down, so it's sort of like the Nipissing story that originally existed? We don't know. Part of the problem is that we can only say, like on a radiocarbon date, we can say plus or minus a good radiocarbon date. A really good one is plus or minus 50 years. So that's 100 years of time. It's hard to pin it down, you know? An optical date, a really good one, is plus or minus 75. So now you've gone out to 150 years of uncertainty. So it's hard to, you know, it's hard to pin it down. So you got to go, okay, let's try to, it's like CSI, you know? So between 2,000 and 1,000 years ago, it was cooler and wetter. And then it got warmer and drier, and that's when things picked up. So if that's true, does that mean that the Lake Michigan dunes are somehow kind of like a drought system, like the plains? When I first saw that, I went, you're kidding me, because the plains, you think of the Dust Bowl and droughts and, you know, grasshoppers and all kinds of bad things, you know. And here you don't really think about that so much, because the lake's right there. But maybe that has something to do with it. One of the things about science is that you just keep coming up with more questions. But here's our Holland interval right there. There's something going on, and it could be that there were just fewer storms, because that's, you got to have wind too, right? Yeah. But if it's fewer storms, that means it's fewer storms for 700 years.
Yeah.
We're trying to, my team, Bill Monahan and Bill Lovis. Monahan is at the Indiana Geological Survey, and Lovis is an archaeologist at MSU. And we submitted a paper to Nature here a couple of years ago. I mean, if you can land a paper in Nature, you're like gold. Yeah. And we submitted a paper based on this to Nature, thinking, hey, we had something cool, and it was rejected in what probably was record time. Whoever reviewed it on the other end looked at the title, and I think I got the rejection back like within 30 minutes. Yeah. So we're going to try again in another venue. We're trying to get more data to back it up. So, at least based on the probability, we think that dunes appear to have grown mostly during transgressive events. Transgressive means the lake is going up. And that's when mostly, and winds are part of it too, right? Mostly. And if that's true, and that seems to be the case in coastal dunes elsewhere on the planet, in marine environments, that when the lake's going up, it's pushing sand up. Kind of nudging sand up onto the beach. When the lake then drops a little bit, that sand can blow. That seems to make the most sense. But that's not always the case. And the dunes tended to stabilize when lake levels fell. Statistically. With some uncertainty built into it, right? Now, I freely admit that. Okay, so if that's the case, now this has been observed in the perch systems. This is like actually been witnessed, and this is from Grand Solomon. We know, because people have seen it and written about it, we know that when the lake goes up, the bluff, those big steep bluffs are eroded because the waves are banging on it.
Yeah.
That any vegetation on here falls into the lake because it's being undercut. That exposes the sand. Wind hits the bluff, moves the sand on the plateau, forming dunes. And then when the lake level falls, it stabilizes because the waves aren't banging into the bluff like they were. And then plants then grow across the dune surface. stabilizing the dunes, and a soil forms. When the lake goes back up, then the cycle starts all over again. This line here represents the soil that was formed during the low phase, and new sand is supplied, and so the dune in that system grows in stacks. Sleeping Bear, Grand Sable, perfect examples. Interestingly, there seems to be a relationship chronologically with what's going on across the northern hemisphere. And this is what we're trying to write into the story right now. We've taken all of our dates from the Great Lakes, from Cape Cod, and Northern Europe. Here's the OSL probability. This is our 162 dates from the Great Lakes. There are 79 from Europe and 27 from Cape Cod. These are the probability. And look, and there's some variability early in the story, but look at this. At 2000, the Holland interval. The Holland interval in the Great Lakes correlates with the same period of time in Cape Cod and in Northern Europe. And the period of times of activation in the medieval warm period and the Little Ice Age in the last 1,000 years in the Great Lakes correlates temporally with the other side. If that's true, and this is what we're working on right now, we're not going to submit it to nature. Who needs those guys? If this is true, then that means that there's something going on with respect to the jet stream. And that would imply storminess, how that relates to storms. So that would mean, this is the jet here, that means that there's something going on between here and the Baltic that is common. And if that's true, that's really interesting. And that means that our dunes here in Lake Michigan really are global phenomena. And I like that idea. So if that's true, then what that means is that when the dunes are active, that's because big storms are coming out of the plains. Think of the Fitzgerald storm, November storms. We're thinking that most of our dunes most sand is being blown during the big fall storms when the systems are strong coming out of the plains. And I had one of my graduate students, I had him map the orientation of 1,200 parabolic dunes. That's what happens when you're a graduate student. and we know that the winds, whether you're at this far north or all the way down to Indiana, it's southwest winds that are driving the dunes, which is amazing to me. This far north, that's the case. All the way to the bridge. So these dunes are, southwesterly winds are blowing these things, probably during the fall season for the most part, when the storms are the biggest, and it may be related to what's going on hemispherically. Isn't that cool?
Yeah.
Mm-hmm.
Yeah, I love that. Yeah. All right, so is there a modern analog? I'm about to wrap up here. Is there a modern analog? One of the cool things about the dunes, and you guys know this, is that landscape changes, right? You go to the beach one year and it looks different than it did the next. And the dunes are the same. I like working on that kind of landscape because I can see the change. I'm fascinated by the glacial history of Michigan. It's awesome, but that's not going to happen again in my lifetime. And if you get 10 glacial people standing at an outcrop someplace, each of them is going to have a different story about how that sediment got there. You just kind of stand there and go, have at it. The dunes, you can see the change. So, what I did was I've looked at the lake level curve since 97. I really do need to update this because this is not, it doesn't reflect the higher water phase that we're in right now. 97, the lake was high. This is about when I started working on these things, 97. You probably remember that high phase. And then the lake fell. It's gone up and down, up and down, up and down, but it hadn't been at the 97 high. So, is there anything just in the lake level changes that we've seen here in the last 20 years that tells us something? All right, so what I've done is I've done some repeat photography. I've gone to the same place And taking a photograph then, taking a photograph now, how does it look? You know? So I got a bunch of sites, but here's two of them, Montague and Van Buren again. Done a lot of work at Van Buren. And here's Montague in 2001. Run-of-the-mill coastline, wide beach. 2001's just 4 years after the 97 high. So the lake was up, it's fallen, wide beach, and here's what it looks like in 2001. That's the first time I was there. So then I went back a few years later just to see what things were looking like, and I tried to find the same place, and I took that photo. There it is in 2008. Okay, look at that.
Were they taken during the same time of the year?
Yes. Now, here's what's interesting, is that one, is that because, see how flat the beach is here?
Yeah.
Well, now this is the receiving area for sand that's blowing onto that surface that was flat then. Now it's blowing onto that surface. Now you're seeing a little foredune grow here. But it's happening slow enough that plants are keeping up. Marram grass. And also notice that this bluff is starting to get more plant cover on it. From a geomorphic perspective, that to me is that the bluff is now stabilizing. Because the plant roots are going to glue it together. There's Montague in 2014. Foredune is bigger. Yep. It's higher for sure. But look how covered the bluff is now. See the difference?
Yeah.
So this, any sand that's here, if the wind hits that bluff, the sand is not going to blow as readily because the plants are holding it together. Whereas back here, if wind hits that bluff, the sand moves easily because it's bare. It's pretty simple, really. There's Montague. Here's Van Buren. Now, keep in mind, this is what I saw the first time I went out there. This is right after the 97 high. And you're going to get a feel for just how lucky we were in our reconstructions based on these sequence of images. Here's 99, there's Van Buren in 99. I saw the guts of these things big time. Lake was up, a lot of erosion. That's what we see. Okay? Really lucky because we see those soils. A few years later, go back to the same spot. Look at the difference. This is one of the few times where I got an audible wow from a freshman in class. Some kid sitting in the back, I heard him go, wow. I nearly retired on the spot. I am not doing any better than this. This is the peak of my career right now. So 2008, and look, this is that marsh deposit, which was over here in the previous slide. Okay, and look, there's already trees growing out of that. Cottonwood trees are growing out of that marsh.
Yeah.
Because it's stable. The lake's fallen. It's stable. Now look at it, 2014. That's just 15 years.
What's the lake level there? As now, 2018, did the lake start
I'll show
coaching
you.
on that?
I'll show you. I'll show you. I appreciate you guys sending me all these questions before I came up here because it's working out perfectly. But this is a landscape that's stabilizing, right? So dunes are stabilizing during the low lake phase, which sort of ties into what the prehistoric record was telling us. So you have some confidence in the story. What about the future? That's what everybody wants to know. This was, here's the lake curve in 2017, this is July 2015, and then this is projected out to July 2018. Obviously there's some uncertainty here for projections in the future, but I got a couple of friends who are lake level people, one at the University of Waterloo, and he said if he was a betting man, he would say that in the next 10 years we're likely going to have a lake phase that is higher than the 86 high.
Wow.
For those of you who were around here then, I wasn't, but I've heard about it, like, whoa, the 86 high. And if that's true, there's the lake level today. If that's true, the lake's going to be another 1.5 feet higher than it is now. And what does that mean for the coastline?
What about dredging and so on in areas? I've heard a speaker talk about people in Lake Huron are angry because the level is lower because there was some dredging done down in the Detroit area, which makes the water higher, and you know the other things. It seems like everybody's got a theory.
Yeah, everybody's got a theory. Occam's razor applies here, the simplest explanation. And the simplest explanation is nature's just doing its thing. I've talked to folks on the lake shore who are concerned about lake levels through my career, and one year the lake is down. And so I've heard people in Chicago's growing too fast. They're taking out too much water. And a few years later, the lake's back up. People in Chicago need to take out more water. And there's no relationship.
Yeah.
From what I've heard, and I'm not an expert on this, what I've heard is that the human imprint on lake level fluctuations, okay, is a 1/2 inch.
Yeah.
And that mostly what's happening is just the lake doing its thing.
There was an integrated assessment on Great Lakes levels, Great Lakes water levels, I think done last year by the University of Michigan, and their conclusion was climate is the driving factor of, whether these lakes are high or low.
Sure, it is. And as I understand it, mostly the primary variable is snowpack.
Yes. And freezing,
yeah.
like, icing over.
Sure, and when the lake, like a few years ago, when the lake froze over, you're not going to get any evaporation there. And so it's a very complex system.
Yeah.
Yes, sir.
How about the rate of change? It seems like the last increase in the lake was much quicker than, at least in my lifetime, I've experienced when the lake has gone up and down. This last one was very quick.
Yeah, it does respond quickly. I know, for example, New York Times has I got a buzz on my phone a few days ago. New York Times has published a database where you can go to most any big city, look at what 2017 was in terms of record temperature and precipitation. Everything that I looked at my hometown, looked at Lansing, other places, was like a couple degrees warmer than average, and precip in a lot of places was above average. Interestingly, for here, and why it might be relevant, is that October in Michigan was way over average. I mean, you had a lot of water dumping on the system at that point. So all that water goes into the lake, and that could be that sensitive. And that's one of the things about a climate change scenario. I have some folks in my department who are working on that, especially in the Great Lakes region. And 50 years out, the projections are that generally warmer. The growing season, for example, in Michigan has increased by 10 days in the last 30 years. Generally warmer, more variable precip, but that precip may be more of it. But that when it comes in bigger chunks.
Yeah. And flooding.
Yeah.
Flooding is the big risk at the local level. For the Grand Traverse Bay region, if you picture it running from Sheboygan to Manistee, basically leaning to the west side of the state, those are the impacts that they're looking at. Increased flooding.
Yeah, because you have more water vapor in the system because there's more evaporation from the oceans, and so it goes somewhere and then it all falls someplace. And that would have a big impact on the lakes. And that response would be pretty quick. So, to the question, what does it look like now with the lake going up? I did the best I could. Here's Montague in 2001, there's Montague in 2008, there's 2017. I was out there, I don't know, when was that, September? Something like that. Couldn't get exactly the same angle, because I would have had to wade out that far, which would have been a better shot, I acknowledge that.
It's like Sturgeon Bay is now. I used to be able to walk along the beach, now you can't.
That's right.
But lake level continues up, then those waves are going to destabilize this, and that plant cover is going to go back, and sand's going to start to blow again. Here's Van Buren again, 2008. I didn't include the 99 shot. There's been here in 2008, 2014, and then we were down there in October when Brad, my fellow Kansan, and I were giving a talk at St. Joe, and we went out that day, and there it was. So I mean, it's a little. The lake was angry that day. It was very windy, and neither one of us were going to go out there. And well, we had to look sort of good. I realize the bar is low, but there's only so much I can work with here. But we didn't want to be soaked. But you can get a sense that that lake's up, and that's going to be. This keeps up. That's going to be gone in another year or two. So it's a really interesting dynamic system, and I love working in it. So we're taking all these new things, and we're trying to actually apply them in some scenario for the state. Let's manage these things. Let's think about them in the way they really are, not what we would like them to be or what we think they might be. This is what they really are, and all of the statutes and everything were pretty much written in before anybody knew anything about their evolution. What does that mean for the future? I don't know. That's for other people to figure out.
I just had one question, it's kind of off topic, but the Sahara sand that's blowing into the Atlantic Ocean, that's coming out of the east, how fast is that growing, that desert pushing into the Atlantic Ocean?
That is a great question.
Do you ever look at that one? That's very bizarre.
Yeah, it is, but yeah, I don't have a clue.
Is that's not considered a sand dune, is it?
Sand sea.
Sand sea.
Yeah.
Okay.
Some of that dust from over there it's well documented. A friend of mine, he was on my PhD committee. Some of that dust accumulates in Georgia.
From the hurricanes? Right?
No, just from general blowing.
Wow.
So like when the sand stabilizes and can support trees and everything, how long are those periods of time usually?
Great question. All right, let's back up here to. Okay, so this one?
Yeah.
These where it's relatively thin, the soil, okay, it's about like that. I'm thinking 150, 200 years.
Okay, because like the ones above it seems like there would be some plants that would like establish there because the sand's not coming in at like massive rates every day.
Yeah.
So like it's just not enough for it to be shown in the profile now.
Right.
Okay.
And this period of time here, this soil right here, that's the Holland interval. And see the tree stumps? Mm-hmm. That was stable long enough that trees were growing in succession. It's really interesting. And I'm lucky to be working on it for sure. We've also been remapping the dunes. We want the state and folks to think of this landscape as diverse, dynamic, and very sensitive. Yeah.
Down by Grand Haven, that Rosie Mound,
Yep.
is that called a parabolic dune, where it's blown out? Can that just happen anywhere along the coast?
Sure.
And what causes that to just blow out like that?
There's thresholds involved. That's the very first dune I ever dated. It sounds a little weird, you know? But what the heck? It is. It's the very first Great Lakes dune I ever dated. And if the vortex of the storm system coming through is just right, bang, that's the spot.
It just seemed really concerning when I saw it, that could happen anywhere, even where there's homes and people living.
Of course.
Wow.
But people, there's all kinds of evidence, right, that people are not very good at living with dynamic landforms. They're not.
Right.
Mississippi floodplain, classic example.
I saw a house at Ludington. It's spent many years at the Ludington Home Storage Plant. Down between there, Ludington, Cutwater. People built homes too close to the bluff, and
Yeah.
they were.
Sure.
By the time I left, he was hanging. His house was literally like feet from the
Yeah.
edge of the bluff.
I mean, New Orleans is the worst sighted city by far.
It's under sea level, 5 feet under sea level.
Sure. So we want the state to think of them as the way they really are. Diverse, dynamic. Sir.
Have you done any research on how human activities are changing longshore drift of sand and how that's influencing sand dune development?
Not my thing.
do you have any guesses as to, I mean, there's so many break walls and
Sure.
dredged harbors, and it's really just
Yeah.
totally disrupted that, which must be tied into it to a big extent.
It's a good question. You can sure see evidence where sand is accumulating on the upcurrent side and whatnot. I haven't really thought about what the implications are of that from dunes like in the last 10, 15 years in terms of sand being supplied to them. It's a good question. It would be hard to trace those sand grains and know that that's where it came from. But my sense of things, I'm on this Great Lakes Consortium where it's a group of like-minded folks that we meet once every 4 months, something like that. And some folks that are working on the lake and whatnot, it's kind of a two-part deal. One is that certainly the structures in the lake are influencing the current. And one of the ways that you're seeing that is that beaches are highly irregular now, the width of them. Another factor, I don't have any way of measuring this myself, but people who supposedly are in the know, another factor is that there's so much shoreline armoring now. People building, revetments and rock and all that kind of stuff. There's less sand getting into the system because it's not eroding from the bluffs because they're protected. So it's a chicken and the egg sort of thing. I don't know what the implications are for dunes. If sand, over the next 150 years, if less sand is supplied to the beach, then that would have an impact for sure. One thing that we have done, and we're working on another paper where we've looked at vegetation change in all the state parks and Sleeping Bear since the first aerial photographs were flown in '38. That was when the first air photos were taken. And in '38, bear sand was everywhere. There was hardly a plant at Sleeping Bear. I mean, it really did look like the Sahara. And then we looked at the most recent air photo, 2016, and we just mapped out the change in vegetation cover since then. And it's incredible how much trees have expanded across that surface, up to 22-25% in some of the parks. And that, I think, is a human thing.
Because there's more protection, there's no dune buggies and such.
Yeah, right. I think that's a human thing. We've also been remapping the dunes. Speaking of Sleeping Bear, we've been remapping the dunes because remember the statutes created maps of the dunes, but they didn't map all of the dunes. They just mapped what they considered to be the best dunes, the biggest dunes. And so a student of mine and I we have created, in the intro there's a reference to that because Brad wrote it, created the first comprehensive map of Lake Michigan coastal dunes. Pretty proud of this actually. It's easy to do now because there's high resolution LiDAR, which is radar imagery. And this is a dune field near Holland. And look how well these dunes, the resolution is like that on this imagery. It's fantastic. And so it's easy to draw the lines where the dunes are, where that did not exist before. And so we've created this first. Here's an example of how it works, what the contribution we might be making. Again, here's high-res LiDAR. The blue that you see here is the critical dunes that were mapped in the '89 statute. And that is what's has been so long considered to be the dunes, the mappable dunes in Michigan. But in fact, our LiDAR work is showing, here's the boundary based on the LiDAR, look how much more. And this is a recent project I've been working on with Brad and his group. One of my grad students is working on this stuff. And so our map includes over 2 times as much coastal dune sand as the critical dune maps did. I'm not saying that the critical dune maps were wrong. They were doing it for a different reason. They weren't looking to map all coastal dunes. They were just looking to map what they considered to be the best coastal dunes. So there's a lot. We're still learning a lot about these things. It's fun to talk about. It's easy to talk about. Groups are always interested in it. So we've done a lot. I appreciate your time.